Okay, so I'm going to speak loudly because one of our mics lost a battery. Brandon's going to help me with mics. So let's just go to Q, and I'm going to let Lee and Lee and you, if you guys want to come up, if you want to stay up here, here's a mic for the two of you. Let's go ahead. Let me just get a quick show of hands. Who has a question right now for either one of me or you? Okay, tell me your name. Ashley, we'll start with Ashley. Let me just see Ashley, then Steve, and then this gentleman, Luke. Okay, go ahead. We'll take these three, and then we'll go back out. So Ashley, go ahead.
Okay. So what about, neither one of you talked about the difference neither one of you talked about the difference between mechanical management and natural management. And the literature tells us that mechanically managing a forest actually produces different species in the long run. Are those species more or less climate ready or more or less resilient to fire in the future? So if we switch to more prescriptive and more management, again with mechanical techniques, maybe some more prescribed fire, but what will that do ultimately to the forests in the long run, species-wise?
Am I going to need to use a microphone? Shall I just simply speak? Do you want me to take that first? Oh, yeah. Oh, please. So I think I get about 2/3 of your question. I wasn't sure about the creating the different species thing. What was that?
Just thinking that if you mechanically manage, and say you put some prescribed fire on a landscape, you can't do as much as you want, mechanically changing the forest, you'll ultimately see species varieties that aren't eventually as adapted to climate change.
Oh, no, well, no, I would disagree with that. I think that mechanically you actually get a lot of choices that you don't have with a lot of the other features. And actually, come on, that's really what some people I think in the community like about the natural system. It's a lot more random, and we're not like, playing God or whatever you call it. But okay, whatever. I mean, I get that. But so the mechanical thing, the beauty about it is that it's not going to start a fire. Well, often it's not going to start a fire. Sometimes people aren't using spark arresters, right? Stuff like that. But it's not going to start a fire. You can do it different parts of the year. And then there's that whole link with at least theoretical links with biomass markets and jobs and secure energy and on and on and on and on and on. So as an ecologist, I would say that where we can do that work, we should do it. It needs to be strategic. We've known that for years. We've been planning this kind of stuff forever. It's a big part of what we do on a day-to-day basis. It's a big part of the controversy of a lot of what we do on the day-to-day basis, with a lot of folks at any rate. I don't think from my standpoint as a scientist, and okay, I work for the agency, so that's, need to admit that. But I mean, the issue is not really the work itself, because we know how to focus on to push the system towards certain more drought and fire tolerant species. We know how to retain certain sizes if we need to. We know how to write prescriptions to do a lot of different things, right? The issues are money. Can you continue to do that work, and where do you find the money to do it? Because we don't work in a command economy, right? There's got to be a profit margin somewhere for somebody for it to happen, okay? And then secondly is the scale. And that's probably the biggest issue, right? That's what it comes down to is, can you, even if you could theoretically treat every acre that you can theoretically treat, boy, if you throw that against the Inyo National Forest, that's 10% of the landscape. Some other forests, it's a lot more. All right, let's be honest. But there's an example that we've heard recently. So I think that's the big deal, right, is the scalar issue, really. Did you want to add anything, Travis?
Yeah, I think that point about not being able to treat the whole landscape is really important. Mechanical is really expensive per acre. Fire is another tool in the box, and it's less expensive per acre. And even with fire, you don't have the ability to burn the entire forest the way it should be burned. And so you've got to focus on places that make the most sense at the scale that will still make a difference.
Go ahead, Steve, and then Luke, and then we'll go to another cue. Go ahead, Steve.
My question is, there was a slide that talked about an increase in precipitation in the southern Sierra Range, and there's the research, there's the policies or practices, and then policies that may be associated with what the outcome of the research is. So if I look at that indication of increase in precipitation, a lot of people are focused on, well, it's going to be rain, it's not going to be snow, there'll be a change in the hydrology. and you're indicating that it's trending as an increase. There's the Kings River experimental watershed that has indicated that it's not just precipitation, but it's the yield or the runoff. And I think a lot of policymakers are going to say, oh, increase in precipitation, therefore increase in yield, and what are the mechanisms that we put in place to capture that increased runoff? What are your thoughts in respect to that?
Thank you, Steve. Yeah, when it's red.
When it's red, it's working. I thought green was working. So I guess I'm not sure what question you want me to focus on, but I guess what I'll say. You're sure it'll pick me up?
Yeah. Can you hear me in the back? Go ahead.
Okay. I just have to look down at my shoes while I'm speaking. A lot of people do that. It's an effective presentation method. In terms of I guess I don't really know what your question is, but I'm going to just ramble on anyway, okay? So the first part of it had to do with the precip thing, and are you concerned that people don't understand the difference between the rain and the snow, or you just want to know, you want to talk about how that is the difference?
Well, again, if you just focus on precipitation and what form, that's one part of the analysis, shall we say. But I'm a policymaker, and I'm very interested in what is the outcome. You know, is it an increased yield or runoff going into infrastructure and utilization of that, quote, additional water, when in fact it may not be the case based on other studies that are being undertaken in the southern Sierras that infer that there's going to be less runoff because of climate change and the fact that the evapotranspiration changes as far as in that region.
Yeah, okay, I get it. Yeah, so, you know, so I really envy like nuclear physicists and stuff like that, because they actually have rules and things happen. You know, chemists, I was awful at chemistry, but chemistry, we got a whole bunch of laws you can follow, and ecology is like, you throw in all these moving parts, most of which we don't understand, and then add evolution and all these other things, and it's just like, wow. That's why we do everything probabilistically, right? It's all kind of like, maybe this, maybe that. We're more likely this, less likely that. So that's what you're getting at, is that our inability really to put our finger on a lot of this. And you know what? It's going to change watershed to watershed too. But I think there are some things that we do know, and we know them from a lot of different studies. And one is that, just for the heck of it, let's say you wanted to take this range back to some level of historic conditions. Okay, you can argue that if you want. Although I tell you, if you argue the point about using historic conditions at least as some kind of reference, maybe that's not the target, but you know what I mean? Like maybe a waypoint, kind of the direction we might want to at least head before we the baby turns adult and we let them go and do their own thing, you know what I mean? Kind of thing. Is that it's going to be warmer and drier in the future than it was during the Little Ice Age, which is when all of our reference conditions come from. So if you think where we're headed in terms of canopy cover and density is too low, then just wait 100 years and see how low it's going to be in 100 years if you just let the system figure itself out. You know what I'm saying? But I think that what happens, I mean, I'm assuming you've walked around in wildfires after they burn. You know what happens to the water table, right? It goes way up. Springs pop up all over the place, streams come up all over, all sorts of stuff. So I don't think it's pretty simple science, and I'm not suggesting remove biomass everywhere. I'm just saying that that's one side of it. Let's talk about it objectively. If you remove the number of straws sucking the water out of the ground, the soil water goes up and the water table comes up and all that stuff. So there's going to be more runoff on average. Now, there are other reasons to have more trees, right? We got to have that dialogue. But from the water side, I think we understand how that thing works. Now, then you added, well, wait a minute, it's going to get warmer. There's going to be higher evapotranspiration. You're totally right. Okay? So this is this thing. I had that slide, maybe remember, about the experimentation and the learning thing. Okay, so I'm a scientist, so again, I'm not totally objective, because like everyone, we're always looking to find out how we answer these questions, because they don't answer themselves, right, without a little bit of investment, or a lot of investment in some cases. But I really think that if we're not committed to learning as we go, then we're in really big trouble, because the way that a lot of, well, I'm not going to criticize the Forest Service directly, because all my bosses are sitting in front of me. No, I'm kidding. But if you just look at the way agencies work, they don't have a choice, right? They get funded to implement. And when you don't implement, oh boy, you got problems, you know? But if you're not learning as you implement, then you don't know anything in 50 years or 100 years. And I can list so many different problems that we have in our agency and in other agencies that have been problems for 70 or 80 years because we've never stopped and said, okay, wait a minute, let's figure out what's happening. and let's see whether, you know what I'm saying? But that's not our fault. That's the way agencies work. That's the way humans work. We want to implement. And I would say that that's one of the real big changes that I think we have to make is because if we're going to experiment in the future, but we don't commit to learning from, and by experiment, I'm not necessarily talking about, like really giant factorial investments in, just pure science everywhere. I'm just talking about following what happens in a standardized way and learning as we go and holding hands with the public. So when we make mistakes, it's not it's everyone's mistake. And we all go, damn, okay, we didn't even do it this way this time. You know what I'm saying? So at any rate, I don't know how else to answer that. But you're right. You brought up a lot of complications, and they're real,
Lee, did you add anything on the precipitation flows, runoff?
The only thing I would add to that is that, snow is a big factor, the snow line and how much of that watershed is going to get a really significant snowpack. So Southern Sierra, there's a lot of snow up top. Northern Sierra, there's not going to be much of snow up top going forward. So that's going to be one of the big factors. And yeah, you've pretty much just got to have a watershed model and do probabilistic stuff. And
so just based on the duration of Dr. Safford's responses, let me take a question from Luke, and then also this other woman, and then John. So in all seriousness, let me take 3 questions in a row, and then I'm going to let them respond to a couple. We're going to do those 3, and then we'll come to Jennifer up front here. Just because I'm interested in time, I want to get a couple questions more from just 2 or 3 people. Go ahead, Luke, and then this woman, and then John in the back. Go ahead.
So you showed that controlled burns happen on the shoulder season when it's not too hot to burn and it's not too wet to burn. And I'm curious about these dry Januaries that they have. They seem to be an opportunity, and I'm wondering, are we able to capitalize on an opportunity for burning in these Januaries? And if we're not able to capitalize on it, what's preventing us from doing that?
So let's take the 3 questions. Go ahead. It's Lucy.
Yes.
what? All at once?
Take them at the same time?
Yeah, go ahead. I want to Just give me a moment. So we'll come back to the one about taking advantage of January as an opportunity for fire.
Okay.
Okay, go ahead, Lucy, and then we'll go John.
This is really going to challenge you guys to see if you can keep all the questions straight. Lucy
Good luck
Blake
with
from Northern Sierra Partnership. In listening to you speak about both the scale and the challenge of the cost, what strikes me is a need for real collaboration, between state and federal sources and private owners, because that's the only way it's going to happen. And there's always been this problem, state money can't be used to do work on federal lands, and so it's by operating at a bigger scale across a bigger landscape that you're going to be able to pool different kinds of money to make it happen. On the private side, it seems to me that's the missing piece, and so I wanted to ask, yes, there's a question. On the private side, I wanted to see if you guys have given some thought to what more could be done to either have tax incentives or cost shares or other things. NRCS does do some of that. I think that's available for private landowners, but I think it's a really important piece for getting the job done.
Thank you, Lucy. John?
Okay.
Yes, John Amadeo with the Tuolumne River Trust. I was wondering if you could respond to the relationship of this emerging trend of mega fires to achieving the state AB 32 goals. Specifically, they assume a certain amount of sequestering by the forest, and as they get less healthy and convert to shrubs and grasses, there'll be less sequestering. And then as well as what is clearly a rapid increase in the amount of emissions from wildfires that I don't believe that were so well accepted or known when they made their assumptions. So, what are the lessons? What do we need to adapt to what we're now learning?
So you had the 3 questions about the January example for prescribed fire, about incentives, state and federal. Okay, go ahead. What's your things?
So I'll go to the January fires first. That's actually the easiest one anyway. So yeah, we definitely, you can't burn until fuels come into prescription. And in the winter, while there are some dry periods, there's still a lot of low angle light, and there's a lot of cold air around, inversions. So things don't dry out as quickly, even if it has been dry for a few weeks or so. But there have been opportunities. They're hard to capitalize on because the windows for burning are much shorter. There's not as much daylight, and then resources are traditionally more available in the summer because they're sort of piggybacked on the wildfire resources. And so we're still sort of working on how to make those, how do we get people available to help make these burns happen in January? And we're working on stuff, and it's a really sort of banal contracting issue, and things like that really sort of still trip us up when I call up the fire guy like, hey, can we burn? No. and that's where we are. We're trying to work through that though. And then
doing some burning.
What's that?
When was the last time you have been doing some burning here? I commend you for it.
Yeah, there was a burn last week in Yosemite. We're trying to,
right now. Basin's burning, Colorado's burning.
When the fuels are there, then everybody's looking for it. Yeah. But dispersion is different in the winter too, so we still don't have a great handle on how to get things, how to loft plumes and how plumes behave with really strong inversions at night, but decent transport in the day, that sort of thing. So.
Next one was sort of collaboration, state, private, federal, NRX fire, and then there was a mega fire question about sequestration.
And I guess as far as megafires and sequestration, the CARB inventory and that process is based on an annual inventory, and the forest sector is not, I don't think, part of where anybody banks on yet. There is definitely, it's part of the inventory, but so I'm not an expert on the inventory. I'm just going to stop there. But
okay, you want to touch a couple of those?
Yeah. Do you want to talk about the other things?
Yeah, sure. I just wanted to say that, there's quite a lot of burning going on. The thing is that most of our burning happens at a real small scale, which is why I personally think prescribed fire on its own isn't even going to come close. It's much less even than the mechanical because of all the smoke issues in particular and the prescription issues, because fire is kind of a scary thing. We want to do as much of it as we can. I'm just finishing an analysis right now with some people in the Lake Tahoe Basin, and when you think about all the things that get in the way of actually pulling off a prescribed fire, it's amazing. I mean, you got to first of all have a day that CARB says, okay, you can burn, right? Which half the time is in days when you can't because everything's covered in 6 feet of snow. More than that, about 90% of the time, that's what it is, right? And then you've got to have it in prescription, right? So it's got to be the right wind, the right humidity. Then you got to have the right people on staff. You got to get a burn boss on staff who can do it, which means during the fire season, you probably don't, well, often you don't have the people because they're in, somewhere in Texas or in Southern California fighting a fire. Then you got to have a burn plan signed. Then you got to have the money, and it kind of goes on and on and on. You end up with a few days a year when you can even burn. But it's happening. I was in the Lake Tahoe Basin all last week, and there was smoke. They were burning what they could burn. The mega fire, I'm going to come back to your question, ma'am, in a second. The mega fire one, I want to make one point that as an ecologist, and I think I would hope that people would understand that in this group, and that is that the Sierra Nevada is not the Olympic Peninsula. It's not the Olympic Peninsula. And it's not the Amazon rainforest. You can't sequester the kind of material in these forests like you can in those places because these forests will burn with a guarantee. They will burn. Okay? So you did a great job talking about that, Lee. The question is not when, but if, but when, and the question is under what circumstances will they burn. So there's going to be an asymptotic relationship. You could probably sequester a whole lot more if you could keep it from burning for another 100 or another 200 or another 300 years, but I'm telling you that that is a stacked deck. And what we need to do is understand that if you can get a lot of big trees in the landscape, you can probably sequester a lot more. To me, the issue is maintenance over time versus trying to maximize the rate of sequestration. This Mediterranean climates are bad places to think about maximizing sequestration over long times. You want to get as much as you can safely on the landscape, maintain it in big trees. You can do it. We know how to do that. All right? And that's the way the system looked, actually. So I just wanted to make that point. And then in terms of the collaboration question, that was a pretty multifaceted question. It was all about collaboration and stuff. I wanted to note that it's kind of interesting that if you go to the northern part of the state, there's a very active prescribed fire council in Northern California, and way more prescribed fire goes on private lands than on public lands up there. A lot of parts of the country, it's the reverse. But that's what goes on up there because they can burn on days that we can't. You know what I mean? And there's a culture. It's kind of cool. It's developing still, but there's a culture there. We don't have that in the rest of the state right now. It's not like some of us have worked in the southeast and some have spent time in the southeast. I don't know if you guys have ever gone down there, but they're burning hundreds of thousands of acres a year. But they don't have the same airshed issues that we have, and they don't have California voters either. Okay.
Okay. Thanks for bearing with me. I know we got about 100 people here in the room. Let me get Jennifer. Who else has a question after Jennifer? Okay, we're going to come this gentleman behind. So go ahead, Jennifer. Take a bundle again.
we'll see 2 or 3.
So this question is for Hugh. I'm Jennifer Montgomery from Placer County, and I actually live in the wildland-urban interface. And that is actually my question, which is your analysis that showed a higher than expected mortality rate for subalpine and higher elevation biomass. Did you analyze as part of that the effects of human development and intrusion into those areas?
Okay, yeah, let me make sure that you understand the patterns that I saw first, because I'm not sure that you understood my graphic, and I don't blame you because I was speaking French and going very fast the whole time. At high elevation, we're not seeing higher than expected mortality, not yet. Okay, I would expect to see it at some point in the future, but I actually have a couple of studies published in the recent years where we've explicitly said that. To this point, we're not seeing that increasing trend in mortality. Okay, so that's important. The second one is we do see a slight effect of fire suppression on fire occurrence at high elevations. We do. It's not very important, and the reason is simple. It's mathematical. Partly mathematical. If you go to a mixed conifer stand where the historic fire return interval was probably somewhere between 7 and 15 years. It's astounding how much fire there was on these landscapes before. Well, have you guys ever read any of those like miners' journals and stuff like that? Oh man, it's just smoky. The sky is just smoky all the time they're here, you know. And when you stop fire for 100 years in that system, you create a profound disturbance because you've removed 10, 11, 12 burning events from that landscape, you know. Red fir forest has a mean fire return interval in California of about 40 years before Euro-American settlement. So 80 to 100 years of suppression, maybe you've missed 1 fire, maybe 2 fires, you know what I mean? So okay, a little bit of effect there. Once you get into lodgepole and subalpine, it just hasn't been long enough for us to have a real effect on that thus far, okay? What is happening is climate almost pretty much on its own is changing those systems. So I don't know how much you guys do a lot of hiking, like PCT, high elevation stuff. There are lots of places where there used to be permanent snowfields. They aren't anymore, and they're just filling in with seedlings. And what we found is that it's not preferential for one species or another, but just that it's like beach time in the subalpine forest. You know what I mean? It's like they're getting still plenty of precip, but the growing season's getting longer, it's getting warmer, and everyone is just making babies everywhere. You know what I mean? And, well, whatever, I don't know how else to say that. And that's what's going on, you know? And so to this point, we can say, we're not seeing that huge subalpine loss that we expected. But as you densify that, and we're seeing more area of fire in those systems. That's what we're seeing, okay? It's not burning much hotter yet, but we're seeing more area. My interpretation of that is that we are sort of beginning to see changes that I expect to lead to more severe fires in the future. Which is, I think the agency's interested in working in red fir. I think we ought to do it and think about how to do it right, you know, though first.
Lee, did you have any add-ins? Anything you wanted? Okay, we'll go to Bob and then the gentleman behind Bob. Go ahead.
I want to ask about fire severity in Yosemite. Did the treatment work that Yosemite had done affect the fire severity? Did it direct the fire away from the areas that had been treated, or did they have less severe burn? And the other side of it is you were focused on the air implications. What about the sterilization of the soil in a severe fire? It seems to me that has a huge carbon implication too.
Well, as for the severity, whether the fire did change the severity, so you're asking whether the fire changed the severity, whether the treatments changed severity within those treatments. Well, they're still doing remeasurement plots and stuff like that. But operationally, I do know that they were using and taking advantage of the changes in fire behavior within those treatments to go more direct at the fire and instead of backing off another couple days and let the fire spread a couple more days. And the numbers thrown around for that area that perhaps was saved was somewhere between 10 and 20,000 acres. Those are just numbers I've heard from the operations people, so take that with a grain of salt. But and then in terms of whether it changed, you know, we'll know for sure once the remeasurement plots are in. But and we used a reasonable scheme to sort of illustrate what we think is happening in terms of severity and emissions and the carbon stocks, in terms of moving the live trees into the dead or the emission pool. We'll know more once the plots are in, and we can write some papers on it. So.
But the soil has been sterilized. you're not going to have regrowth nearly as quickly.
And that's something that Hugh might be more familiar with than I. So I don't know.
Well, I would say that one thing that, actually fire, even when it's very high severity, typically only impacts the top couple inches of the soil, but not always. It's usually post-fire events then. You know how it can get really ashy, et cetera. You can have erosional events and then remove a lot of topsoil. I would say that soils in the Sierra Nevada are adapted to a lot of fire, maybe not quite so much high severity fire, so it's a lot more resilient. And remember, the range is largely built on metamorphic and granitic rocks, so they're kind of granular soils often as well, not quite as clay, and so as a result, the post-fire soil structure doesn't change quite as much as you might anticipate. Now, what I would be a little bit more worried about, but hand in hand with this, is the size of those patches of mortality that we're seeing in recent fires. There were patches in the rimfire that were more than 10,000 acres, in which there was 95% mortality. And so what happens is that there's sort of a rule of thumb that once you get about 2 tree lengths or so beyond like the last living trees, that you start to see a huge drop off in the amount of seed delivery into the system. And then that becomes the question of, oh, is this ever going to become forest again, or will it in our lifetimes, et cetera? That's a good question, and that's where we do a lot of our planting, and it is in those kinds of situations. To me, there are some soil issues, but I think that those have to be taken in context with sort of the scale of these fires. The total amount of high severity fire that we see on the range today, so this is an important point, I want to make it, that although we have way less fire, orders of magnitude less in an average year right now than we would have seen in the historical system, except in the last 3 years. We've had a lot, okay? Even though we have that big deficit, the amount of snag habitat that's getting created is really similar to what we would have seen historically, because the fires are so much more severe, right? So when you get hundreds of thousands of acres times maybe 2, 5, 10% of the area is real hot versus, a tenth of those acres, but 30, 40, 50% of the fire is that hot, it adds up to the same amount of habitat, but it's happening in mountainsides now, instead of little patches that can succeed to chaparral, be early Sierra for a while, but then kind of turn into a mosaic of young forest, old forest. Now we've got these big patches of old forest and young forest and medium forest. It's a very different system than that system that was so resilient that was here when we moved into it.
Thank you. We got about 2-3 minutes left, so we'll take David's question, then we'll see where we are. Go ahead, David.
So, Hugh, your little story of biotic change over the next century in the Sierra from the foothills to the upper montane is pretty grim, pretty ugly, I think, for most of us in this room. I don't really want to live in a grassland. I'm a little unclear to what extent you think that can be forestalled with intelligent management, and for how long can it be forestalled? If I was a policymaker and you told me, well, you can put it off for 50 or 75 years, but it's going to do the same thing anyway, I might really question whether the Sierra was worth the investment.
Okay, and so you just want to know to what extent I feel as if this is something we're spending any time on? Oh boy, hot seat, huh? Holy cow! So here's what I'll say is that, yeah, I do think you can make a really, really, really big difference. I mean, on the one hand is the whole emissions thing. Okay, that's not a separate question. It's a similar question. So there are mitigation questions in areas the size of the Sierra Nevada going, and that is a big part of what we're talking about, although we're really talking about adaptation right now, but it's a mitigation issue. It's a huge one as well. But yeah, I think you can make big differences. I think that, let me just say one thing. If you go to places that are like California, similar climates, other parts of the world, but have had human habitation for thousands and thousands of years, i.e. the Mediterranean basin, they've got forests all over the place, all right? It's a lot of management that goes into keeping a lot of those forests on the landscape in a lot of places, all right? A lot of us, we've got this amazing wilderness system in this country. It's one of the things that sets management here apart. And one of the things that you guys are going to be talking about at this National Park Symposium at the end of this month, right, is what do you do in a system based on preserving the past where the past isn't preservable anymore? Right? I think you guys got a much bigger problem than we do, so I should be asking you the question. No, but yeah, absolutely you can make a difference. But so when you look at what the models are suggesting, and I think what you can do is, I think you have to come to grips with the fact that there's a lot of the forest that's going to be dominated by hardwoods in the future if we can keep it in forest. I don't think that's bad. You know what I mean? I don't think it's necessarily a bad thing. They sequester a lot of carbon. They provide a lot more wildlife habitat. Probably. People love them. They're pretty, Nice oak wood floors, all sorts of that kind of stuff. Great firewood, You're going to be able to maintain conifers on a lot of the landscape as well. too, but it's going to take management. And I think this is why I spend a lot of time in Europe. We have a Mediterranean kind of program through our International Programs Office, and those guys are centuries ahead of us in terms of where they are in landscapes. So is Southern California. You want to go down and learn some stuff, just drive around the Southern California mountains, because they're dealing with the problems that we're just starting to deal with. They've been doing them for 10, 20 years. So yeah, no, I'm optimistic about the possibility of of forestalling that on large areas of the landscape, but it's going to take a real serious effort, and hence this effort, right?
Let me just check, Lee, did you have any closing remarks before we take a break? Go ahead.
I would just say that the fires that burn at this low and moderate severity, they leave behind those big trees, and those big trees continue to grow as we speak. And so as we try to minimize our impact both on air quality and on carbon, it's just we've got some initial science that talks about the effect of fire on carbon stocks, and that the low and moderate severity fires haven't really had much of an impact, at least in the pine and the lower elevations, on the carbon stocks. It's really the high severity stuff that looks like it's got the potential to change. So we want those big trees there, and we want to keep them growing, and we want to keep them growing for as long as possible. So maybe even if they're destined to eventually succumb in 100 years, that's still 100 years of growth and carbon sequestration and keeping the CO2 out of the atmosphere until we figure out something better, maybe. So I would just make that point, and that's it.
So let me add one thing to that, because he made a really good point, and that is that, so it's not only the carbon, because he was referring to if you can change the way fires are burning in the system, because they are going to burn, and it's a big issue, right? You end up in a situation where not only do you preserve the larger trees in the landscape, and then you've got the carbon benefits and stuff like that, but that's also the way that system stays on the landscape, right, when you think about it, because that's the way the system stayed in the landscape forever. It survived through, you remember that fire in mixed conifer and yellow pine forest is not really what I would call a disturbance factor as much as it is a maintenance factor, right? So you don't just preserve carbon, but you preserve the ecosystem, because you know what the big trees do. All that matters to them, well, this is a silly generalization, but to a great extent what matters to them is what the climate was when they were seedlings, because that's when they germinated, grew, got their roots into the bedrock, and man, a big tree can survive a whole lot of climate change if the forest lets it do it, right? And in the case of the pines, you need low density, because if you don't have that, then you got beetle issues, you got disease issues, and you got fire issues. And so it's just a big cycle. And I think we know what to do. I think we know how to do it. It's just a question of whether we can make it happen at the pace and the scale necessary to realize a real effect.
A round of applause for our speakers.